Thanks everyone for joining this session and a warm welcome to all of you. When we talk the search, the responsiveness is very important. Uh, Typically a search application which is offering a lower latency and it can help you to drive the user adoption as well as the revenue growth. Let me tell you two scenarios where actually that highlights that why having a lower latency monitoring is crucial for you. In the first scenario is about a product owner who is managing a very popular travel application, and he finds that after few weeks their search adoption is going down, and they are unaware that the travel applications, when customers are coming, they are finding it very lengthy to use, and that is why they are moving to the competitors. So in this scenario, that particular product owner is unaware, they do not have any direct visibility to the search latencies, and hence their whole customers are moving to a competitor's application and they are losing the revenue. Let me tell you a second scenario where a cluster administrator who is managing 1000 plus node cluster, and that particular cluster is serving hundreds of queries every second, and cluster administrator wants to further optimize the hardware as well as the tuning, but they do not have any direct means to do that. So the common point in both the two scenarios is a missing link, which is a feature which can give them the direct ability to have a query latency monitoring ability. So today I am very excited to talk about Query Insight. It is a product which can offer you out of the box query monitoring ability, and that too with the real time data. So there is you don't need to wait. As and when the queries are performing, you will get to know. So I am Siddhant. I am working as a senior product manager with AWS. So how best do we describe the OpenSearch? So as we know that OpenSearch has been in existence for a very long time, and recently I just remembered from my previous colleague from the Intel who mentioned that Lucene is one of the engine which has been in existence for close to 25 years. So which is great, and OpenSearch fundamentally is using Lucene. So the best way to describe OpenSearch is it is constantly evolving. It was used for the OpenSearch for the search for specific applications, and then people also started using it for the log analytics, and most recently customers, they have also started using for the GenAI as a vector DB. So OpenSearch is very good application or the platform to use for the vector DB. So in a nutshell, OpenSearch has been constantly evolving, and that is a true testament to its capabilities. So let me focus something about the search latency. So always there has been some ways in the OpenSearch to have some kind of monitoring ability, and you can figure out that how is the performance of the search latencies. Specifically, if you look at the below 2.11 versions, we had node states and the shard slowness, but they all are at the shard level. They are not at a coordinator level. So typically what happens when a search request comes and hits to your cluster endpoint, if you have a dedicated coordinator node, then great. Otherwise, one of the node will be elected as a coordinator, and then coordinator node will figure out where that particular request needs to be routed, and all the data nodes who are having those specific shards will receive those requests, and then coordinator node will collect all the data, aggregate, and send the response back. So the journey between the first point when this particular search request hit your coordinator node and all the way response is sent back to the client, we call it as a latency. So until 2.11 we had the latencies more in terms of the shard level, and starting from 2.11 we started offering at a coordinator node level. So you get a complete comprehensive view about what's going on at a different shard level as well as different phases of your query. We also started offering the phase to parameter, and then the search request slow log, which I am going to talk in a minute, and finally the query insight, which is product which we will dive deep. So if you look at a API which is about the search slow log, so here you can see that different configurations you can set at what moment you want to capture when your search is slow, and when those search thresholds are crossed, your log will be recorded, and it offers you certain parameters like how much time it took in the milliseconds, phase took milliseconds, total hit, the type of search which is fired against your search. So this is all great, you can figure out, but still what you are missing is kind of visualization aspects, and also how your hardware is consumed, how your resources are consumed which are involved in serving a search request is still missing. So that is where the query insight comes into picture. So query insight is a framework which offers you few advantages over others. First, you find the latency of your search queries itself, then you also find the resource consumed, and then the ability to visualize in a dashboard. So top features about the query insights are, the very first thing is the top n query. So you can, all these are configurable. So you can say that I want my top 10 queries, and based on my resources, which is CPU and memory consumption. Then there is also a detailed query metadata, because when query it hits multiple aspects. It is like index, you want to know the shards, and you want to know the date, timestamp, node ID, etc. There is a query exporter. So once you have this visualization, you can also configure that all the logs which are generated by the query insight framework, you have a choice. Either you can store it in your local index, or you can also export in the OpenTelemetry format. And finally, the dashboard, where out of the box you can see the lovely visualizations. Now, why query insight is important? So query insight is important because it offers you, the very first thing is identification, because until now it is very hard for a search developer to figure out that what are my queries and how they are performing. And also there is a lot of noise. Consider like you are having a really big production environment, and it is receiving hundreds of queries. There is lot of noise, right? So how do you cut the noise and still focus on the queries which are really taking lot of resources? Then the second thing is optimize your resource allocation, because first thing is identify. Once you identify that these are my queries, then you can do something about it, like either you can structure your index differently, or you can fine tune your query, or you can scale your cluster if that is the need. And then it also helps you enhance the troubleshooting, because it addresses the metadata and query execution, so that you can pinpoint exactly where the change required. So this is about the architecture. So as you can see, there is a active request listener which is keep on listening as and when a request is hitting your cluster, and then all the mechanisms which I told you, coordinator node, and then the data node and all the indexes. And then once your request is executed, it continuously stores the data into the memory. So in memory there is a data, and then there are a couple of processors like top end query aggregator, which is very lightweight. It doesn't consume lot of resources. So suppose if you are looking for a top end query on the CPU, so that it will perform that specific job to just aggregate the data and send it back. And of course everything happening in the OpenSearch thread pool, and from the thread pool you can push data to two ways. There is a OpenTelemetry support, and from OpenTelemetry you can take to any the dashboard whatever you like. And then there is a local index where it can light up the query insight dashboard which comes out of the box. So let me take you few examples so that the concept is clear. The very first example is about you want to know the top end query by the CPU. So there are total 4 steps involved. The very first step is about, you will say you want to enable the CPU. Then second thing is about the window time. So you can set up like 30 minutes on all the way, whatever window you want, 1 hour, 2 hour window. So every that 30 minutes, in this example it is 30 minutes, so 30 minutes window will be monitored. Then next one is how many ends you want, so 10, 20 or whatever number you want to set. And finally, how to retrieve the top end query by CPU. So there is a command. So the first 3 steps is like you configure it, you get the data, generate the data, and finally you will export it to the data. You can get it, or you can also export it to your local indexes. So in the response, you get the 10 queries that is used most of your CPU resources. So this is like a API example, and in a moment I will share the dashboard example also, where you don't need all these things. Here is another example which is about the latency. So here, like in the previous, there are 4 steps, here also 4 steps, everything is same. It is just instead of query CPU, the only difference is you can say that your latency enabled true, and then it will go with the latency, and of course window size, everything is variable. Now comes to the exporting the data. So as I mentioned, you have like 2 or 3 different ways. You can export to local index, you can export as a open telemetry. So you can say in this example, like I want to trace the latency. So latency is true, and then your exporter type is your local index. You can mention the date and time stamp or that particular log. And finally, this is another example which I was telling about how do you cut the noise. So if you are like having a really production scenario which is receiving lots of queries every second, and then you want to cut the noise, because if you set top end query and all the queries are more or less same, suppose the only variable is user ID, right, or the department ID, and then still they are taking lot of resources. So it generates lot of noise. So it will be very difficult, because if you set say 100, all 100 are belonging to the same pattern, but you will miss the next 110 or 120 query, which is really important for you to address. So with this feature, what you can do, you can cut down the noise. You can say that, okay, I want to enable the similarity, right, and I want to exclude the top 100 queries and then export it, so that you get the visibility, not only the top 100, but also you have a ability to cut the noise and say that, okay, all the treat all the same queries similarly, and then rather than the top 100, just say that, okay, this is group 1, group 2. So like that you can figure it out. So this is another example, like how the group similarity can help you. So in this example, query term is same, but the user ID value is different, and they all can like consume lot of top slots, say top 100 queries, but they are only differing in the value A and value B. So now let me move to the dashboard, which has been missing in the whole equation, right? Because so far there is a search log, there is a different APIs, but what a average customer look for is a direct, easy to view what are my top end queries and how is their resource consumption pattern. So the very first thing is, how do you enable it? So it comes as a plugin. So you go to the dashboard, you go to the query, there is a plugin section, and then you will find the query insight, and okay. Yeah, probably the background is black, next slides are like white, so you will be able to see. Also I want to just provide the visibility that there is also a playground in the OpenSearch. So if you are not having in your own setup, you can always go and it is like available, there is no access or registration required. Like right away you can go to the playground in the OpenSearch, and then you can find this plugin with the data, and then you can see your queries. So once you are into the query insight dashboard, this is how a typical dashboard will look like. As I mentioned, it is out of the box, it provides you real-time data. In this example, what you see, like lot of the queries which are running, so there are like couple of attributes which I want to walk you through. So the very first thing is the exact query ID which is getting executed, the query count. If you enable the group, based on the similarity, you will see like the number of query count may be more than 1, because they all are the same. But in this example, it is only 1 for now. There is a timestamp, the date and time when the query execution completed. There is a latency, there is a CPU, there is the list of indices. If a query is hitting more than one index, you will find more than one index name here. The search type, because there are different ways you can write your query. So query search type also you can see. The coordinator node which acted as a coordinator, and then there is a total shards which are involved here. On the filter side, you can see the query and the group. There is a indices which you can filter. That suppose if you want to really focus on couple of indices and you want to see in the entire universe how many queries are hitting that particular indice, you can do that. Coordinator node also you can focus. This will be specifically useful if you have a dedicated coordinator node. And then one useful feature is your ability to go back to the past data. So this is like a real time data, but you can always go back like last 24 hours or 7 days. So by default it comes with 14 days, but you can configure because every value is configurable. So let me so if you like click on any of the line item here, suppose the very first line which is a query, so you will further drill down and then you can see the exact query which is fired. You can see the different phases in the query. So in this example it is expand, query and fetch, how much each phase is taking time, and then couple of other information like indices, search type, coordinator node involved, and then the total shards involved. So this is another example where you have enabled a group. If you click on that particular group, you will find mostly the same detail, but everything is in the terms of average, because what happens if say there are 10 queries which are caught in that particular group, then based on the similarity, so everything will be in the aggregated at a average level, and these phases are at a average level. So little bit about the configuration. So everything is configurable. You can very well configure about the metric type. You can see here latency. You can also enable latency, CPU and memory. You also have ability to define what are your top N, your window size, and then also group by whether you want to enable it or not. And then finally you can set your exporter, whether you want in the local index or you want to as a open telemetry. So just to summarize, query inside API support starts from version 1.2, which is about the API support, and then the dashboard support we offer from 3.0, which offers the advanced grouping, dashboards, as well as the historical trend analysis. Here is like further reading which you can figure out, like there are a couple of blogs which my colleague have written about the query insight and also the group by clause and how to use it. So I think that's all from my side about the query insight. I am happy to take any questions.
So for example, in our environment, we don't have a coordinating node. So we have all data nodes and then all master input. So how you support that? So I understand that such latency and all can be captured, but like CPU, how will measure exactly? So because these nodes are responsible for indexing, coordinating.
So one of the data node will act as a coordinator node, right? So that particular CPU we will account for.
But the same node is responsible for other activities.
Sorry to interrupt, sir. Just for the benefit of us.
The same node is responsible to doing other activities also. So for example, if we say have a 12 core CPU or something like that.
Correct.
So will you?
So only part of it. So whatever, so it is, you understand, like one coordinator node might be handling like hundreds of requests, right?
Correct.
So we are like each node, how much CPU is consumed, we are tracking at that level.
Okay.
Right. So only part of it.
Okay. Okay. So the such time it makes sense. Like you'll be
Correct.
Based on the slow log, you'll be taking into the account and then you'll be aggregating.
Correct.
Okay. Okay. Thank you. Thanks.
Does that mean that you are tracking the CPU, the cycle used at the thread level?
Not at a thread level.
Because ultimately the thread mean the CPU thread I'm talking about, right? That executes your search.
We are not tracking at a thread level. It is at a time component. So suppose in 1 minute, say 100 queries are running, so what part is consumed?
Oh,
Not
okay.
that way.
So, okay, got
Not
it.
at a cycle thread level.
Okay, got it. Thank you.
Yeah, my first question is basically, is it available in the managed clusters?
So in the managed cluster right now, we are like the visualization aspect, as I mentioned, that visualization comes with 3.0. So the APIs are available for Query Insight, but as we launch the 3.1, it will be available in the managed service.
3.0 is not available in the managed service.
3.0 is not available in the managed service. Managed service, we will launch the 3.1, which is happening sometime.
Yeah, so it's in the roadmap.
Roadmap.
Okay.
Immediately do alternate versions of the managed service.
Right.
So you had 2.19, there's 3.0, there's 3.1. And when 3.1 comes out in the service, it will automatically.
And what about the API support? Do we
It is available.
in?
It is available in 3.19 also. It's available. As I mentioned, that API support starts from 2.12 onwards, so it is
The
available.
Insights API,
Yes.
you can use it over there. And one more thing is basically if I'm say that like I have a sample query, I want to check how the latency and like the fetch phase, everything over there. In the playground, can we do it or?
Yeah, you can do it in Playground, of course.
So can we try out different queries and in real time see like what
Yeah.
is the
Yes.
okay, I'll try it out. See.
So these query insights, are these also supported for the hybrid search or only for the normal lexical searches?
No, it is supported for all query types.
All query.
Yes, because if you see, like there is one query type is there, right? So that differentiate what kind of search you are having.
Yeah, I think we're around a time. Okay, let's leave the last.
So this could actually helps immensely to
Absolutely.
take that search. So on the related note, are you extending that for indexing? So how much time it is indexing document is taking time? So that is what we get from the index stats actually. So for this index query, how much time it is taking? And also, right, so now we are going into segmentation. So how much time this this merging is taking care?
So for the index level support, we are doing for managed service only. We don't have any plan for the open source. I mean, open source we don't dictate, so
Okay.
people can always contribute. But yes, at a CloudWatch level, we have a plan.
Okay. Okay.
We
So-
can discuss offline.
Okay. Thank you.
Thanks, Siddhant, for the
Thank you.
presentation.
Thank you.